Hello everyone, welcome to my channel. In this video, we are going to break down the UGC NET Computer Science previous paper of the year 2004, paper 2. There are actually 50 questions. We will cover 25 questions, first 25 questions in the part 1 and remaining 25 questions in part 2. I will explain the key concepts in simple terms and provide tips and tricks to help you ace the exam. So, whether you are a beginner or an experienced aspirant, this video is for you. So, let's get started. The first question, A or A equals to A is called dash. Identity law, idempotent law, De Morgan's law, complement law. In digital logic, we are having different types of laws on the Boolean algebra. Okay. Here in the given law, A or A equals to A. So A or means addition and logical operator means product. So if you are adding an element with itself, it is giving that element itself, right? So idempotent law states that combining a quantity with itself either by logical addition or logical multiplication will result in a logical sum or product that is equivalent of the quantity. So the correct answer is idempotent law. So here we can see the table of different laws or theorems in the Boolean algebra. So in the identity law, so if you are performing the addition of the same quantity elements here, then it is giving the element itself, right? So here I am multiplying the same element with itself, then it is giving the answer itself. And the remaining options are not satisfying that particular law, that is De Morgan's law, identity law. Right. So in most of the competitive exams, they will ask identity law and idempotent law because they will be little bit confusing, right? So this is a main point here. So next one. Second question. If f of x equal to x plus 1 and g of x equals to x plus 3, then f circle, f circle, f circle, f. So here circle means f of. Okay. So the given value, the given expression results in f of x, right? So here, so it is giving the 4 f's, right? 1, 2, 3, 4, 4 f's. Okay, f of x. So what is the f of x value here? X plus 1. X plus 1, right? So here we are considering this f of x value is x plus 1. So we have to consider this value as x and substitute it in the particular relation. So here f of x plus 1. Okay, so f of x is x plus 1. So we are considering this value as x and substituting it in the f of x value itself. So this will give x plus 2, right? X plus 1 plus 1. So we are substituting this, considering this value as x and substituting it in the f of x value, x plus 2. So f of x plus 2. Okay, so you have to consider this value as a x value and substitute it in the f of x value. Okay, so then it will result in x plus 3. So f of x plus 3. So substitute consider this value as the x plus 3 value as x and substitute it in the f of x value. It will give x plus 4. So the answer is x plus 4. But here in the options it is not given as x plus 4. Then how can we write this expression here? So given that g of x equals to x plus 3. So we can write the x plus 4 as x plus 3 plus 1, right? So here the f of x plus 3 means g of x. That means g of x plus 1. Okay. So the answer is B, g plus 1. Right. So in this way we can substitute this relation. Next one, third one. The context-free languages are closed for intersection, union, complementation, clean star. See, these type of questions are asked in many competitive exams. So you can observe the questions on the regular languages are closed under which type of relation. Context-free languages are closed under which type of relations. They may ask context-sensitive languages, the Turing machines. So how the recursive languages, recursive enumerable languages. So on which language they are covered or they are closed. So these type of questions are mostly repeated in many of the NET, GATE and ISRO type of exams. So here the closure properties of the context-free languages. The context-free languages are closed under these properties, that is union, clean closure, homomorphism, concatenation, substitution and reverse homomorphism. And context-free languages are not closed under these properties, that is intersection and complementation. So here in the given option the answer is C, right? So here these languages are closed, the context-free languages are not closed under intersection and complementation, right? So that's why the answer is union, clean closure. They are closed under union and clean closure. The answer is 2 and 4, right? C. Next. The following list are the degrees of all the vertices of a graph. So here given some degrees of the vertices of a graph. Okay. So given here in the order. So we need to find out the sum of the vertices. We know that there is a handshaking lemma. It states that every finite undirected graph that has an even number of vertices with odd degree, that is the sum of vertices theorem. So the sum of vertices theorem, sum of the vertices is equals to 2 times the edges. That means the sum of vertices will be even. So we need to find out the sum of the degrees of all the vertices in the given options. So for the first option, 1 plus 2 plus 3 plus 4 plus 5. Okay, so 1 plus 2 plus 3. 1 plus 2 is 3, 6, 4 plus 5, 15. Then 15, right? So this is the sum of the degrees of the vertices. Next, second one, 3 plus 4, that is 7, 12 and 18 and 18 plus 7, that is 25. So here the sum of degrees of these vertices is 25. And 1 plus 4 plus 5 plus 8 plus 6, which is equals to 24. And 3 plus 4 plus 5 plus 6, that is 18. So this is only the sum of the degree of the vertices. So here equals 2 times the edges means that sum of the vertices must be even. Okay. So here in the given options there are only 2 options which are even, that is 24 and 18. So that's why this is the answer. 3 and 4. Options 3 and 4 are the answers. Next question. If IM denotes the set of integers modulo m, then the following are fields with respect to the operations of addition modulo m and multiplication modulo m. So here the options given are Z23, Z29, Z31 and Z33. So here we have to know that what is meant by field first of all. What is a field? A field is a thing where you can add, subtract, multiply and divide. Okay, so here the ZP, that is the ZP, the value here at the base level, it must be a prime number. Okay, suppose if ZP is a field, then P must be a prime number always. So we will see this in the given explanation. A set Zm integer modulo m is a field if addition modulo m forms an abelian group and multiplication modulo m forms a group. So here both the addition and multiplication must be distributive. And whatever the value that we have given here, Zm or Zp, it must be a prime number. So we will solve each option in the given question. So Z23. So 23 is a prime number, right? So it is a field. So whatever the value here, it must be a prime number. And it must satisfy the addition modulo m and the multiplication modulo m. So next step. Z29. So here 29 is a prime number. Z31 is a prime number. And Z33. So it is not a prime number because it can be multiplied by 3 and 11. So that's why it is not prime. So here the options are, correct options are 1, 2 and 3. Okay. So here a field means it must follow the addition and multiplication. Okay. So it can follow addition and multiplication. So here it is following so these options are satisfying the given answer. So 1, 2 and 3 are the answers. Next one. An example of a binary number which is equal to its 2's complement is called dash. So in the given number, we have to find out the binary number which is equal to its 2's complement. So how can we find the 2's complement? So first of all, we have to find out the 1's complement of each value, and then we have to add the 1's complement with 1. Then we will get the 2's complement. So we have to check each option here separately. Okay. So here given option A, so 1, 1, 0, 0. We have to apply the 1's complement here for this one. So it will give 0, 0, 1, 1 plus 1. That means the answer is 0, 1, 0, 0. Right? Option A. And next option B. So what is option B? 1, 0, 0, 1. So we need to find out the invert here, right? So that means 0, 1, 1, 0. Okay. 0, 1, 1, 0 plus 1. That equals to 0, 3, 1. So these values are the 2's complement of the given options. Next, C, option C, 1, 0, 0, 1, 0, 0. So the invert of this number is 0, 1, 1, right? So it will give the value 0, 1, 1 plus 1. That equals to 1, 0, 0. Next, option D. So 4 ones. So here the inversion of 4 ones is 0s, 4 zeros plus 1. That equals to 0, 0, 0, 1. Right. So if you observe the given options, so A, B are not same, but C is same, right? So if you are applying the 2's complement for this value also, the result is itself. So it is satisfying the given question. So the option, correct option is C, right? So this is the explanation of this question. So option is the correct option is C. Next one. When a tri-state logic device is in the third state, then it draws low current. It doesn't draw any current. It draws very high current. It represents a low impedance. Okay. So normally we have only two states for a particular logical device. That is on and off. Then what is this tri-state logic? Okay. So here in a tri-state logic device, It is a type of digital logic device that can exist in one of the three states. That is logical 0, that means low level, where the output is at a low voltage level, and logical 1, which is high level, that is the voltage level is high, and third state is the high impedance state. In this state, the output is effectively disconnected like an open circuit. In this state, the device doesn't influence the circuit it is connected to. So in the high impedance state, bus systems, it is used in the bus systems where multiple devices share the same connection lines. So the third state of the tri-state logic has high impedance, hence resulting to a low current. So the correct option is A. An example of a connective which is not associative is. So we know different types of connectives, right? AND or not, XOR, XNOR, and then so they are asking which connectives are not associative. So this type of questions were also asked in the previous exams, right? In the NET GATE exams. So they will ask like this, or they will ask which connective is distributive or which connective is not distributive, which is commutative, which is associative, like this they will ask. Okay. So here associativity. A binary operation like a logical connective is associative if the result remains the same regardless of how the operands are grouped. So AND gate. So here associativity means grouping of the logical operators, logical operands. Okay. So A and B and C is equals to A and B and C. So here the result is remains the same regardless of the grouping. And in the OR gate also it is happening same here, right? So regardless of the grouping of the elements here, the answer is same. For NAND gate also it is same. For NOR gate also it is same. But for XOR gate it is different. So A XOR B XOR C is not equals to A XOR B XOR C. So that's why the correct option is XOR connective. So it is not associative. It is not following the associative property. So we will know about the commutativity also here. Okay. But it is not given in the question, so it will be useful for the further exams. Commutative means that the order of the operands doesn't affect the result of an operation. So remember one thing, associativity means grouping of the operands, but commutative means order of the operands. So A and B equals to B and A. OR gate. So A or B equals to B or A. A NAND B equals to B NAND A. And A NOR B equals to B NOR A. A XOR B equals to B XOR A. So these are the properties that satisfy the, so these are the gates that satisfy the commutative property. AND, OR, NAND, NOR, XOR. Okay. So these are the properties that satisfy the commutative law. Next. Essential hazards may occur in which type of logical circuits? Combination logical circuits, synchronous sequential logical circuits, asynchronous sequential logical circuits working in the fundamental mode, and asynchronous sequential logic circuits working in the pulse mode. Essential hazards can occur in asynchronous sequential logical circuits working in the fundamental mode. Actually, there are three types of modes, that is static, dynamic, and fundamental modes. And essential hazards occur in the fundamental mode. Essential hazards occur due to the delay in different classes of different flip-flops. This results in the logic not performing its function properly. These hazards may occur in the asynchronous sequential logic circuits working in the fundamental mode. So due to this type of hazards, there is an glitch that can lead to incorrect operation in certain scenarios. This will happen when a change in one input causes a momentary glitch or unexpected change in the output before it settles to the correct value. Next. The characteristics equation of a T flip-flop is. So these are the different characteristic equations. So first of all, you must know the characteristic table of the T flip-flop. Then you can easily answer this question. So the answer is A. Right. So we know that the T flip-flop follows the XOR property, right? XOR gate. So this particular equation is following the XOR gate, the XOR expression. So that's why the answer is A. The next one. Suppose x and y are two integer variables having values 0x 5abc, b6 and 0x 61cd respectively. The result of applying bitwise operator of and to x and y will be dash. So here, we need to perform the bitwise operator to the values, to the hexadecimal values x and y here. Okay. So first of all, we have to convert these hexadecimal values into binary values. Then we can perform the bitwise AND operator here. So we are converting these given values, so 0x 5a b6 into binary values. So binary value of 6 is 0110 and b is 1011 and a is 1010 and 5 is 0101. So first of all, we must know the binary values of each integer here. Okay. So after finding and in hexadecimal numbers, we will represent the binary numbers in 4-bit format, right? And in the octal numbers, we will represent it in the 3-bit format. So here we need to perform the bitwise AND operation of these two values. So x and y equals to that. X and y equals to, so we need to perform the AND operation here. Okay. So if you want to perform the AND operation, then both the bits must be 1. Then the result will be 1. Otherwise, the result will be 0. Okay. So 0 and 1, 0. 1 and 0, 0. And 0 and 1 is 0. So the result will be 1 only if the two values are 1. So after getting the bitwise AND operation, so we need to convert this binary value again into hexadecimal format. Then only we can get the answer here, because the answer is given in the hexadecimal format. So 4 and 8 0 4. So 4084 is the answer. So 0x4084. So this is the answer. Consider the following statements. Int I equals. So now we will consider this following statements. So given an expression here, int I equals to 4, j equals to 3, k equals to 0, and given the expression for k. So we need to find out the values after this expression, the I value, j value and k value. Actually, if you run this same code in the C programming environment, it will give undefined behavior. It depends on the compiler how the answer will be, and there is absolutely no guaranteed answer here. But if you calculate it manually, the answer will be like this. So int I equals to, initially the I value is 4, j value is 3, k equals to 0. Now first we will consider the k value. So I is 4 here and j is 3. Like k is 0. So k is 0. So we are solving this expression. So the first one is the pre-increment I. That means we have to first increment the value and then write in the expression. So 4 plus 1 is 5. Next minus decrement j. So first we need to decrement the value of j by 1 and then write. So 3 minus 1 is 2 plus I post increment value. So what is the I value here? So now the I value will become 5, right? Okay, and j is 2. So post increment I. That means first of all we have to write the value, then it will get incremented. So I value is 5 itself minus pre-decrement j. So pre-decrement j means first we have to lessen the value by 1 and then write it here in the expression plus j post increment, right? J post increment. So j post increment means, so first we have to write the value 1, then it will get incremented. Okay, so after writing the value it will get incremented here 1 to 2, and here in the I also, so it is a post incremented. After writing the value it will get incremented here to 6. Okay, so now evaluate this expression here. So minus 1 plus 1 will be 0. So 5 minus 2 is 3 plus 5, that is 8. So k value is 8, I value is 6, j value is 2. So answer is 6, 2, 8. So this is the answer. Next question is 13th one. What is the value of the arithmetic expression written in C language? So this statement is written in C language. 2 into 3 by 4 minus 3 by 4 into 2. So we have to decode this expression. So let us solve this expression. 2 into 3 by 4 minus 3 by 4 into 2. So this one is 3 by 4 into 2. Okay. 3 by 4 into 2. Okay. So now 2 3 by 6 by 4 minus 3 by 8. That equals to, so if you take the LCM, you get the 1 minus 0. That equals to 1. So here the C language will treat all expression values as the integer. Next one. A function object. So what is meant by a function object? A function object is also called as a functor. So it is an instance of a class for which operator is a member function. The parenthesis is a member function. A function object, also called a functor, is an instance of a class that overloads the parenthesis operator, that is a function call operator. This allows the object to be used as if it were a function. So this is a simple example of how the functor will work. Next one. Polymorphism means. So polymorphism means, poly means many, morphism means forms. So a function, so this a variable can be in many forms. That is called as a polymorphism. So it is an object-oriented programming concept that refers to the ability of a variable, function or object to take a multiple forms. Polymorphism is a runtime type identification within a class hierarchy. A language that features polymorphism allows developers to program in the general rather than program in the specific. So the option is B. Next. The ER model is expressed in terms of entities, relationship among entities, attributes of the entities. So what is meant by entity relationship model? In an entity relationship model, it describes interrelated things of interest in a specific domain of knowledge. An ER model is composed of entity types which classify the things of interest and specifies relationships that can exist between instances of those entity types. For suppose if you are considering the ER model of a company, in the suppose in the insurance company, there will be employee and manager. So here the employee will act as an entity and the manager is an entity, and each entity will have certain attributes, right? So employee will have its ID and name. Similarly, manager have ID and name. So these are the properties of the entities or attribute values of the entities. And there is a relation between the employee and manager. So this relationship is called as, so this diagram is called as the entity relationship model. And employee also has a relationship with the customer. Okay, so like that, so we can draw the entity relationship diagram of the insurance company. So here for the given question, the answer is B. That is 1 and 2. Entities, relationship among the entities. Specialization is a dash process. So we know that there are two types of process, that is specialization and generalization. Specialization is the reverse process of the generalization, and it is a top-down process in object-oriented design or database modeling. It starts with a general concept, for example, a superclass or parent entity, and break down it into more specific specialized subclasses or sub-entities. So in this manner, so these will get divided. This involves adding detailed attributes or refining the behavior for the specialized entities. A general entity like animal can be specialized into mammal, bird, and fish. So all these entities are a part of the animals. So these are all animals, right? In database modeling, a general entity employee can be specialized into sub-entities like manager and engineer. Similarly, an employee can be, so he can be divided into sub-entities like a manager and an engineer. Okay. So specialization is a top-down process, whereas the generalization is a bottom-up process. So these are having the contrast process, right? The answer is a top-down process. The completeness constraint has rules. So supertype, subtype, total specialization, partial specialization, specialization, generalization, and all of the above. There are two rules of completeness constraint, that is total specialization and partial specialization. So the answer is B. So the completeness constraint in object-oriented modeling has rules related to total specialization and partial specialization. So first of all, what is the total specialization? So we know that specialization is a top-down process, right? And an entity, the super entity will be divided into subclasses. So in the total specialization, every instance of the super type must belong to exactly one subtype. Right? If there is a parent class, there must be only one child class. This ensures that all possible variations of the supertype are covered by the subtypes. Okay. The next one is the partial specialization. An instance of the supertype may belong to 0 or 1 subtype. That means the instance of the supertype, that is the child class, will be 0. That means there won't be any child class, or there will be one child class. So 0 or 1 is the option for the partial. Whereas in the total specialization, there is only one subtype which is exactly like the supertype. This allows for flexibility where not all instances need to be classified into a specific subtype. Therefore, the correct answer is B, total specialization and partial specialization. So these are the examples of the total specialization and partial specialization. So let us consider an example of employee hierarchy. So in the employee hierarchy, there are full-time employees, part-time employee, and the contractor. So every employee must fit into one of these categories. There is no room for an employee who does not belong to these categories. So this is the example of total specialization. Whereas in the partial specialization, there are vehicle types. For example, vehicle types. So vehicles are of different types like a car, motorcycle, and truck. So however, there could be vehicles that don't fit into any of these categories, such as specialized vehicles like construction equipment. So the construction equipment won't come into the category of vehicle. So the partial specialization means there will be 0 or 1 subtypes. So next one, the entity type on which the dash type depends is called identifying owner. The answer is weak entity. So weak entity will be always depending on another entities, right? So if a person is weak, then he will depend on other person. If an individual is strong, then he will do his own work, right? So similarly here in the entity ER models, the weak entity will always depend on its owner or a strong entity. So in ER diagram, a weak entity is an entity that cannot exist independently and depends on another entity called identifying owner for its existence. So consider a database for a university. The entity course might be a strong entity here. Course is a strong entity with its own primary key course ID. On the other hand, section might be a weak entity. So section will be a weak entity here. So which is depending on the course. So if the course is not existing, then the section also can't exist. The section is completely dependent on the course. Okay. So this is about the 19th question, weak entity. The answer is weak entity. Next one. Match the following. So here they have given the normalization forms, that is 2NF, 3NF, 4NF, and 5NF. And they have given the options here as the properties, the basic property of each normalization form. So we have to match these two things. So we know that in second normal form, it does not contain any partial function dependencies. And the third normal form, so the third normal form will not allow transitive dependencies. And fourth normal form, multi-valued values will be removed. And fifth normal form, there is no joint dependency. So here the correct answer is B. Right. So 1D. So 2NF removes the partial function dependency, and 3NF removes transitive dependency. 4NF removes the multi-value dependency, and 5NF removes joint dependency. Here the options are not properly matched here. So the first option is having C, and second one 3NF has transitive functional dependency A, and multi-value dependency B and D. So C, A, B, D. So here it is not matching with anyone. The options are not properly given here. Next one. What item is at the root after the following sequence of insertions into an empty split tree? So here they have given the options. So here they have given the values to enter into a split tree. So first of all, we must know what is meant by a split tree and what are the operations that can be allowed on a split tree. A split tree is a self-balancing binary search tree with no balancing condition. The split tree has a property that recently accessed elements can be accessed quickly. It performs all normal operations that are performed on the binary search tree, but there is a special operation called splaying on a split tree. Splaying means arranging the elements of a tree in such a way that the most recently accessed node will be placed as the root of the node. So remember this point. So the recently accessed node will be placed at the root of the tree. So here in the given sequence, so the last one is the recently accessed one. So this will be placed at the top of the tree. So there is no need of drawing any split tree here. So the simple condition is the most recently accessed one. So we will start from the 1 and then we will insert the elements 11, 3 into this binary search tree format. So we will follow the binary search tree principle to insert elements into a tree. But the rule is the recently accessed one will be placed as the root of the tree so that it will be easier to access. So the last one is 2, so which is the recently accessed one. So it will be placed as the root of the element, root of the tree. So the answer is B. Okay. And here in the split trees, we perform 3 types of cases here, that is zigzag step, jig step and jig step. In the zigzag case, there is an left followed by a right rotation, and in jig step, left followed by left rotation, and in zig step, so only left rotation is allowed. So here zig means left rotation and jag means right rotation. Next one, 22. Suppose we are implementing quadratic probing with a hash function hash of y equals to x mod 100 if an element with key 4594 is inserted and the first 3 locations attempted are already occupied. Then the next cell that will be tried is. So here we are applying the quadratic probing for the hash function, that is hash of y equals to x mod 100. So whatever the value that you want to enter into the memory, so we have to apply the we have to take that value and perform the mod operation with 100, and then it is placed in the memory location. Okay, so here the given hash function is h of y equals to x mod 100. So what is the element that we want to insert here? So we want to insert 4594 here. So 4594 mod 100. So if you perform the mod 100 of this element, then you will get the remainder as 94. That means we can place the element in the 94th memory location. But here they have given other condition. The first 3 memory locations attempted are already occupied. That means the memory location 94, 95 and 96 are already occupied. So this is the 94, 95 and 96. So these locations are already occupied. Okay. So then we can place the element in the next location, that is in the 97 location. Okay. So we can place the element 4594 in the 97 locations. The answer is 97. So we can place it in the 97th location. Next one, weighted graph is. So weighted graph, what is meant by a weighted graph? So we have two types of graphs, right? Weighted graph and unweighted graph. If an edge is denoted by any weight or a value, then it is called as a weighted graph. A graph in which each edge carries a value is said to be a weighted graph. Right? That means in a particular graph, if there is any value here between the two vertices for an edge, so 3, 4, 2, so like this, so it is called a weighted graph. So it may be a bidirectional or directional graph. Okay, so this one won't follow, so this also won't follow. It is a graph in which number associated with an arc. So this is the correct option. C is the correct option. So next one, what operation is supported in constant time by the doubly linked list but not by the single linked list? Double linked lists are easier to manipulate because they allow fast and easy sequential access to the list in both directions. But single linked list cannot access to back node or previous node. So we know that there are two types of linked list, that is single and double linked list. In the single linked list, we can traverse only in one direction. Right? So this is the single linked list. And in the case of double linked list, so double linked list means, so we can traverse backward also. We can traverse forward as well as a backward direction. So in the case of a single linked list, we can't access some previous nodes or back node. That's why the answer is the backup here. Next one. How much extra space is used by the heap sort? So for this, we have to know the time complexity and the space complexity of the heap sort. Heap sort also computes with the merge sort, which has the same time bounds. So for heap sort, it will consider big O of 1. So this is the space complexity of the heap sort. So this type of questions will be asked in many competitive exams, like what is the average time complexity of merge sort, or what is the worst time complexity in the binary search space. So like this, they will ask some questions. So this concept, the time complexity and the space complexity of searching and sorting is also very important. So this is about the first part. So in the next video, we will cover the second part. Thank you.